Okay, hi everyone. Now we're going to take a look at lesson 14-3, which is all about graphing lines in this format that we got used to earlier in the school year called y equals mx plus b form, which you see up here as the heading. This is going to allow us to have a shortcut of how we can graph lines without always having to do that table that we saw in the last one. So if you compare y equals mx plus b to this first question, which would have been our do now, you can see that in the m spot, you have the value 2. And in the b spot, you have the value 3. So our slope or our rate of change for that line is 2, and the y-intercept for that line is 3. You're going to see how that affects our graphing process in a few moments. We also see that we have an m value of negative 2/3 for that second question, which also could be written with the negative on the top with the 2 like I already did, or with the negative on the bottom, since a positive divided by a negative overall is negative. The b value is negative 4, so we would have a y-intercept of negative 4 for that. So the slope or y-intercept form for a line is this y equals mx plus b. So that m represents the slope of the line, or the constant rate of change for the linear equation, whereas the b represents the location where the line intersects with the y-axis. So the graph of a line is created by plotting this y-intercept first. Because if we know where we hit the y-axis, or where it intersects the y-axis, we're going to know one of the points of the line right away. And we're going to use the m value, the slope, to find at least 2 more points on the line, although you're going to see me find a lot more. So we're going to be using this y equals mx plus b a lot today. Okay, so let's take a look at graphing the positive slope version of this. We talked about positive slopes a little bit yesterday. They're the slopes that go up and look like they're increasing over time. What I notice here first is we have a -1 on the end. That's telling me my b value is a -1. So if I go onto my graph, what I can do is know that on the y-axis at -1, I'm going to have the line have a point there. It is going to hit the y-axis exactly at that spot. Then I can look at the other number. In this case, it's a 2. So that tells me my slope is the number 2, or when we write it as a fraction, 2/1. What that does for me is it lets me know the rate of change. And what you might remember from our previous chapter is the rate of change is better known as the change in y divided by the change in x. So we now know that everywhere along this line, even from the point we already graphed, the y is always going to change by 2, and the x is always going to change by 1 to get to the next line, and point on that line, I should say. So what you're going to see me do in red on this graph, which I'll erase in a little bit, is show you the motion of what I mean by the change in y is 2 and the change in x is 1. I can go up 2 and over 1, and then I'd know I have another point there. Up another 2 and to the right another 1, I'd know I'd have another point there. And I can keep going up 2 over 1, and you get kind of this staircase pattern. Now that's not the line. Your line doesn't zigzag like that. What that's doing for us is it's showing us where all of the other points of this line end up getting to. And if I get rid of the red portions that I drew as the staircase, all of these green dots that are left are going to end up being points of the line, because all of them are up 2 and right 1 from one point to the next. And you can also do this pattern backwards. So going up 2 and right 1 is the same thing as going down 2 and left 1. So we can add more points going in that direction as well. And that allows us to actually connect our dots still just like we did. Oh, sorry, it glitched on me. Just like we did on the sheet yesterday. So let me go ahead and show that to you. Here we go. They all line up. And so just to recap that one more time, what we have going on here is we had a y-intercept of -1, this end number on the equation. So I started at -1. Then from there, I found some more points by noticing our slope was the fraction 2/1, which I got from the 2 in front of the x. So that tells me I go up 2 and right 1. So from that first point, up 2, right 1. Then up another 2, right another 1. Up another 2, right another 1. That keeps finding new points for me. This also works with ones that are negative slopes. So this one over here still has a y-intercept. It has a y-intercept of 4. So that tells me I can go in on my graph, go to the y-axis at +4. Then I notice the number in front of x is -2. That tells me that my slope is -2. And when you write that as a fraction, it's the number -2/1. So every other point from this starting spot, this y-intercept, is going to be -2/1. Or in other words, down 2/1. Down 2/1 on repeat. And that's going to help me, oops, wrong spot there. That's going to help me find the rest of my points. So if I go down 2/1, that's a point from the line. Down 2, right 1, another point. Down 2, right 1, another point. And I can connect all of those to form a line. So if I go ahead and take a straight edge and line all of that up, there we go. We can form that line, and we don't need that staircase effect there at all. Now, something you heard me mention about slope during the do now problems and that set of information is that this is not the only way that this fraction can be written. The negative sign does not only have to be on the top. For you to have -2, you could also do 2 divided by -1, and that would still create the number -2. So that tells us that from our y-intercept, we don't only have this one that we just used as a rule, we also can do a different combination of the change in y over the change in x. So if I go back to the y-intercept, I can also use that 2 as a +2 and go up 2, and then use the -1 for the x and go left 1. And that's going to be another spot. I can go up 2, left 1, and that's going to be another spot. And that can even find us some more points along this line. So those are shortcuts of using the y-intercept and the slope to graph lines that increase or decrease over time. From yesterday's notes, we already saw shortcuts on how to do these two types of lines. Something that has 0 slope or is a horizontal line, that ends up taking on the form of a function still, but it's when y is always 3. And that is all of the spots that are 3 above the x-axis at a height of 3. And so we get a horizontal line. As opposed to something that has undefined slope, which is going to end up being an x equals equation, in this case x equals 3, that ends up being a vertical line. So that is when x is always equal to 3. And so that's all the spots right 3 of the y-axis. And that gives us this vertical line. So what we're going to be able to do is take the 0 slope and the undefined slope, those bottom two problems, and just always do questions like that in that way. The positive slope and the negative slope, numbers change with those. So they might have a slight different look as you get different numbers in there. Okay, so we're going to see a few more example problems of that real quick. But you can always start at the y-intercept and then use slope as a fraction to see where it goes from there. So for this first one, in problem A, we have y equals 4x minus 1. So what you'll notice is that we have negative 1 as our y-intercept, as our b value. We can begin there, b for begin. So we're going to go ahead and start on the y-axis at negative 1. From there, we can start using the m value of 4 that we see in front of x. As a fraction, that's 4 over 1. So what I can do from my y-intercept is go positive 4 in the y, up 4, and over 1 on the x, positive 1 on the x. That's going to be another point. And then I can go up 4 and over 1 and find another point. Or I can go up 4 over 1 and get another point, but I run out of room. I don't have any more room on the graph there. So if I wanted to be more accurate and I wanted to find some more points, I can start going the other way. So another way that you can get that slope to work for you is if you had negative 4 over negative 1, because negative 4 divided by negative 1 is still positive 4. So from my y-intercept, I could also go down 4 and left 1, and that's going to find another spot. And then I have enough room to do that one more time, down another 4 over another 1 to find another spot. Remember, these staircases you're not supposed to be drawing. You're supposed to be using that as motion. And what you're going to end up drawing is only the connection of all of these dots. So what I'm going to try to do here is get my green back because it is gone now. Unfortunately, it is blocked for me. There we go. Get my green back. And I can connect these dots to form a line that connects all of them. Light green instead of dark green, but it'll work. They're connected. All right, so I'm going to start going a little bit quicker. So for this one, it has a y-intercept of 10. So what that tells us we can do is we can start on the y-axis at 10. So if I count all the way up from 0 up to 10, that's the very last spot that we have room for on the graph here. If you look in front of the x, you have a negative 3 there. That's telling us our slope is negative 3, or as a fraction, negative 3 over 1. So from my y-intercept, I can go down 3 and right 1, down 3 and right 1. And I can keep doing that over and over and over again as much as I want. And that's going to create a whole bunch of points that are all in a line. And if I connected them with a straight edge, I would get my line. Okay, let's look at C. C here already has a fraction in the spot where slope is. We're going to use that second. First, we will use the y-intercept, b for begin. So we will start at negative 1. That's our first point. Every point from there will be done by the slope of 2/3. So if we compare that to change in y over change in x, that means we're going a change in y of 2 and a change of x of 3. So that means up 2, right 3. Up 2, right 3. Up 2, right 3. But I can also not only use positive 2 over positive 3, but negative 2 divided by negative 3 is still 2/3. So I can actually also go down 2, left 3. Down 2, left 3 a couple of times. And that would still allow me to go ahead. Oh well, wrong color. That's fine. And connect the dots. And so that would create my line. We'll do one more of these, and then we'll do 2 more of the special cases, and then you should be good to either rewatch the video if you need some extra help and understanding what the slope is doing here, the m value, or you can move on to the homework. So we have a starting value of 4, a b of 4. So I'm going to go to 4 on the y-axis and put a dot there. I have a slope of negative 1/2. That can have the negative on the top, or it can have the negative on the bottom. I can do either of those. So from my y-intercept, I can either go down 1 and right 2 over and over and over again to get a whole bunch of points that make the line, or I can use the other version of it right here or I'm going up 1, left 2, over and over and over again. And all of these will line up and connect to form a line using your straight edge. Okay, let's look at these special cases one more time, and then you should be good to rewatch, like I said, or you can go ahead and try the homework. So y equals 8. Y equals always are going to be functions. They're going to be horizontal lines because y determines the height of our points. This means all of our points are floating 8 high up in the sky. So we have a horizontal line at a height of 8. Whereas if you go over to this one, x equals -3, x controls left and right motion. So this one's saying x is always -3, so we're always to the left 3. All points to the left 3. And that creates that line. So that's how we do horizontal and vertical lines. Okay, so rewatch if you need more help, or you have these examples which are going to be posted to the Google Classroom page for you to check if you want to try those on your own before you get started on the homework. Otherwise, you have your homework. So please remember, you have the ability to graph these lines because B value, the number at the end, is your starting amount. You start there on your y-axis. And then from there, you use the slope to travel up and down according to the numerator, and then left or right according to the denominator. All right, I hope to see you all Monday, and I hope you have a great weekend.